Welcome everyone back to our program this morning or afternoon, depending on your time zone. We're going to have now two talks prior to an additional speed networking session. Our first speaker in this section is Dr. Kirsten St. George. Dr. St. George is currently a medical director of molecular infectious diseases, and she's at the also the director of the Virology Laboratory and Viral Diseases at the Wadsworth Center in upstate New York. She has an extensive career in the area of infectious disease test development, surveillance, assay development, and applied research. Most recently, all of her combined expertise has been instrumental and extremely critically important in guiding New York state hospitals in their response to the SARS-CoV-2 pandemic. And with that as background, I would like to welcome Dr. St. George and turn the podium over to her. Dr. St. George.
Thank you very much, Carl. Can you hear me clearly?
Yep, we can hear you.
Thank you, Emily, and thank you very much for the invitation to speak this morning. I'd like to point out that the New York State experience is not necessarily indicative of every state public health lab. Every public health lab is different, and New York is one of the large public health labs, obviously, in the country. Not necessarily the most highly processing lab of all of the labs in the country, but it is a very large public health lab. And additionally, we have a saying here that I have spent a lot of time in recent years since coming to public health 16 years ago from a previous 20-year background in academic medicine, and prior to that, many years in, several years in basic research. But in public health, in influenza, we say when you've seen one flu season, you've seen one flu season. And the same can be said for outbreaks. Every outbreak that we handle is very different. And certainly this one has been no exception to that. And I think one of the prominent features of the coronavirus outbreak, apart from the fact that it's been gigantic, has been that the lab testing side has been so prominent for the entire duration, and if anything has increased in its role in steering what is happening in the management of the outbreak. And that has been a really interesting thing to see. We always play a role very early on in detecting and monitoring what's happening, but usually the lab's role subsides after the early phases of an outbreak or even a pandemic. But in this outbreak, in this pandemic, it has sort of continued and increased, and the need for testing and testing capacity nationwide has just continued to be extremely prominent, and that has been very interesting to observe. So without further ado, let's move on. Quick conflict of interest statement declaration. I do have research support from Thermo Fisher for the evaluation of reagents and assays for the diagnosis and characterization of viruses. I also have collaborative agreements and support from Mnemotics and Covaris and Casper, and a royalty generating collaborative agreement with Septometrics. So quick overview of what I'll be covering. I didn't want to start with regulatory aspects, but it just fell out that way when I did the final assembly. It was the best and easiest place to put it. So we'll cover a few things there. How our scale-up of operation panned out, what we did here with the adjustment to other services, our test sources, and some comments on the R&D activities, because Wadsworth Center, the New York State Public Health Lab, has a very strong mission on research as well as public health as a strong component of our public health service. So with regard to the regulatory aspects, so part of our public health responsibility in being a major international portal, we watch the global movement of viral infections and outbreaks very, very carefully through things like ProMed reports and all sorts of other electronic data feeds. And so we were obviously, as most other people, we were well aware of the events that were happening in China. And when this sort of thing happens, we start looking at potential assays and assay development very, very early. And we were already doing that well in advance of February. As we'd have in previous outbreak situations, we did the same thing with Zika, we did the same thing with numerous previous situations such as this. And we had things already well in the pipeline before we actually were in a situation of needing them. We did receive the CDC assay, and I'm not going to talk about that situation. It's already been extensively reported on in numerous venues and sources. And we also submitted our own EUA to the FDA. That photograph on the right was taken in my office on one of the submissions. And I honestly don't remember if that photograph was the original submission or one of the amendments, but it was a fairly historic moment because our EUA was the second EUA ever submitted for SARS-CoV-2 just shortly after the CDC's submission. And so the first other than the CDC's, and the first ever from a public health lab. And so it was a fairly substantial achievement. And our experience with the FDA was actually a very pleasant one. And we subsequently submitted a number of amendments. Our first submission requested authorization to operate the test in the state public health lab and the New York City public health lab. And the subsequent amendment, which in addition to some additional instruments and chemistry changes, requested expansion to several of the hospital labs around New York State who requested access to the test as well. And the FDA came back and said, look, we're going to authorize you to distribute it to whatever hospital clinical labs around New York that you choose, rather than restricting to the several that are listed on your application. We're going to give you more widespread authority to distribute it to any of the New York hospital clinical labs that you choose, that you have regulatory oversight of through the Clinical Laboratory Evaluation Program in New York, which was quite unexpected. And through a series of discussions and calls and subsequent interactions, which I won't go into the details of, they also subsequently granted us permission to not only oversee this test, but all other EUA tests submitted for the testing of New York State patients. So basically gave us the authority to have oversight of EUAs for New York State patients. So basically gave us regulatory authority over the EUAs in place of the FDA. And that was also a very unexpected move. So the whole landscape, as we know, for regulatory oversight changed quite dramatically. And then along came serology assays and things sort of freed up even further. And that has been quite controversial. And now we're moving on to the next wave of EUAs where they are inundated with applications at the FDA and having to sort of focus on point of care assays and high throughput assays for SARS-CoV-2. And we'll soon be moving on with focusing on some of the multiplex assays that are in the process of being submitted for multiplexing flu A and B and SARS-CoV-2 in preparation for the coming flu season. And we've been involved in the validation of some of those assays as well, very much needed for the coming flu season to help streamline what we don't know what's in store for us, but we certainly need to be well prepared for that. We, like everyone else, had to go through a tremendous scale-up of operation with instruments and platform diversification. The photograph on the right with myself and my Associate Director, Megan Ficino, and Assistant Director for Research, Darryl Lamson. The first time we ran our own New York SARS-CoV-2 assay, which was there completing it just after 1:30 in the morning on the 1st of March. but we scaled up with an increase in our automated extractors, the EasyMag and eMags, adding those. We had to bring in a lot of Easy Ones initially to process the CDC assay because that was initially cleared on those extractors only. We also brought in some MagnaPures, and we increased the number of robotic liquid handlers that we had. We already had QIAgilities, but we just increased how many we had to help with the throughput. And the 7500s, the FastDX and the Fasts were our workhorses for the real-time PCRs on both the CDC assay and the New York assay. We were running both. And we already had quite a few of those, but we had to bring in a lot more to increase the throughput capacity. And then we also had to diversify the platforms. We brought in Cepheids, initially the Gene Expert and more recently the Express, to be able to process some samples that were coming in that needed extremely high rapid throughput individually rather than being placed inside the larger batch throughputs. And then for high throughput of large batches, we brought in two Pneumotics DXs, the DX 288s, which the 288 refers to actually how many samples they can process. If it's a DNA assay, for RNA assays, it's about 250 per 8-hour shift each. So those two instruments together can process about 500 per 8-hour shift. And then we also had a couple of GenMarks to also test either the SARS-CoV-2, or we were using them more predominantly to do respiratory virus panels early on when we were still monitoring for additional respiratory viruses. We also developed serology assays at Wadsworth. This work was not done in my own labs. There's another director, Dr. Bill Lee, who is the director of the Diagnostic Immunology Lab and spearheaded the work for these. A total antibody microsphere immunoassay done on serum from venous blood, one detecting the SARS-CoV-1 antigen, another more recently detecting SARS-CoV-2, N and RBD antigen, and those are the assays currently in use for clinical testing. Also an IgG, IgM, and IgA specific MIA assays against the SARS-CoV-2, N, and RBD. They are in FDA at the moment for approval. So also a CLEP approved, that's the New York State regulatory system approved IgG MIA assay from dried blood spots, which has been extensively used in serosurveys against the SARS-CoV-2 N and spike. And we've also done quite a lot of work with plaque reduction neutralization assays using the BEI strain in Vero E6 cells. The scale up also involved a lot of staff surgeon training. There's some of the group there in one of our laboratories. This is some of the, quite a few of the original virology team. The photograph was taken during the pandemic, but these were members of the team before the pandemic. And we went from original virology staff of 29 to a surge staff of 130. The surge came from multiple sources, other diagnostic labs at Wadsworth, some from research and environmental labs, and also from some of our core facilities, particularly the sequencing core. And other state agencies provided some staff for data entry. And we have a JIT, just-in-time training program, that we have used on previous occasions that works very well, rather than cross-training staff and maintaining a cross-trained staff for many years on end and maintaining competency and so on. We find it far more efficient to use a JIT training program in these situations. We also implemented changes to our shift schedule. We normally operate 1 8-hour shift per day. We had to go to 2 8-hour shifts per day. We never went to a 24 hours a day. And we changed from 5 days a week to 7 days a week operation. And we had to go to a lot of space expansion. We took over several additional laboratories, and people were incredibly gracious about vacating the laboratories and allowing us to just move in and take over laboratories in several areas of the building. We did have to make adjustments to other services that are provided by the Wadsworth Centre. We maintained influenza surveillance. for two reasons. At the time, we were still in the midst of some the influenza season. This was in very early March. We still had pediatric deaths. Excuse me. We still had pediatric fatalities from influenza, and we also are a national influenza reference center for the CDC, so we carry the responsibility with that contract of surveillance for 23 states of the United States, and we felt that we simply had to maintain that service. Likewise, for VPD surveillance, we are also a national reference center for vaccine preventable diseases. There on the right is a photograph of shingles, and having experienced the massive measles outbreak in recent years, we felt we also had an obligation to maintain that service. Rabies testing was a photograph of the rabies lab taken inside the rabies lab, also there, was also maintained. Candida auris testing, which probably familiar with, as also a very serious problem in healthcare, was maintained. TB, bacterial meningitis, and so on. Some limited reference testing and antimicrobial resistance testing was also maintained, but most other services were shut down. Notably within virology, all other general virology testing was shut down, respiratory, gastrointestinal, exanthematous diseases, and so on. Of note, our viral encephalitis program was shut down. This was a very difficult decision to make. It's a very extensive encephalitis molecular testing program, and all other non-COVID research testing was also shut down. In terms of the tests that were accessed, the patients that we were testing initially were in emergency departments, primary care, and hospitalized. And then it moved on to nursing homes and other long-term care facilities and correctional facilities, Department of Correctional Services. More recently, there's been a focus on healthcare workers and nursing home staff and pre-procedural patients. And this has shifted actually from being tested here at the Wadsworth Center and public health labs, and a move to move the testing increasingly to commercial laboratories and other clinical testing sites, and not so much in the public health labs. And now, of course, there's increasing calls to test returning students, to colleges, and eventually possibly high schools and other educational facilities. And as we know, sample types became a huge issue. Initially, we all wanted nasopharyngeal swabs. This was considered by most people to be the optimal specimen type. Oropharyngeal swabs as well. Nasal swabs were preferred by some. They're obviously much more comfortable to collect for most people than nasopharyngeal. Sputum, when there were deep chest infections, and VAL a lot less frequently. Mid-turbinate swabs were considered by some to be as good or close to as good as NPS and a lot more comfortable to collect. We've seen and heard enormous number of reports about the pros and cons of saliva and some odd sample types such as tongue swabs and things that we didn't usually used to consider. We've done quite a bit of work now on CSF, a lot of interest in encephalitis, COVID-associated encephalitis and encephalopathies, and we're also asked to test a few unusual things such as peritoneal fluid for surgeons performing procedures, abdominal surgery, where there was the risk of aerosol production on COVID patients. And of course, we also went through all sorts of issues over different types of transport media. Swabs ran out, we looked at 3D printed swabs and so on, just endless supply chain logistics, which continue to this day, and not much chance of them subsiding. I think the problems are still ongoing for most of us. So our outbreak testing capacity back in 2009 with the flu pandemic was about 200 specimens per day. During the Zika outbreak, it went to 400 specimens per day, actually a little over that. And with the SARS-CoV-2, the COVID-19 pandemic, we pushed it up to 2,600 specimens per day. Our total specimens tested now is at about 92,000, and we have detected approximately 8,000 positive cases, and that's a graph at the bottom showing how that testing has flowed. I apologize, there's no y-axis on that graph, but the highest peak that you can see there is at the 2,600 specimens in one day point. And I'm sure for all of you, you can imagine trying to manage staffing and workflow when there is such enormous fluctuations in incoming specimens per day is extraordinarily challenging. And if you also notice, the positivity rate down there in red has dropped to extremely low. It's down around about 2% now. So we have indeed very much flattened and reduced that curve in New York. This is a photograph of me on the left with Greta Van Slyke and Sarah Grisma, two people who assisted me enormously with research throughout the pandemic. And just to show a couple of things that we've done recently with pooling, as I mentioned, research is a major initiative, always considered a significant responsibility at the Wadsworth Centre for Public Health. We're always interested in the science as much as helping to feedback testing data in the early stages of any outbreak and pandemic. And we were, like everyone, trying to find ways to increase our throughput as well as generate data for people who were interested in trying these sorts of strategies to help with their throughput as well. And we were particularly concerned, as was everyone else, about the prospect of decreasing the potential for decreasing the detection, particularly of weak positive samples, those with high CTs. So we took specifically specimens with high CTs and pooled them with negatives in pool sizes of 5 samples, pool sizes of 9 samples. I won't go into the specifics of why we chose those pool samples. It's in the manuscript that we published on this, and demonstrated that in pools of 5 samples, we did not lose the detection of any of the positives, even when the CTs were well up in the 30s, mid 30s. And but when we pooled with 9 sample pools, we lost the detection of several of those weak positive samples. And so we determined that 5 sample pools were really the maximum that we were comfortable with going with. Of course, the logistics are very difficult. While the throughput is increased for extraction and detection and so on, the logistics at accessioning and receiving an accessioning on the front end and then deconvoluting the results and reporting at the other end can be extremely difficult. So this is not always a simple exercise by any stretch. We also did some saliva studies, which were just recently reported. This paper just recently went up on medRxiv, and this was done in a very high prevalence population. The original study back in March, where we showed that sensitivity in nasopharyngeal swabs to be almost 98% and almost 10% lower in nasal swabs and saliva. And we were not very comfortable with that. Over the course of the intervening months, we've had to say, you know, we've come across patients where there are some odd situations where people can't have nasopharyngeal swabs collected and even nasal swabs collected, and so you have to go for alternatives. But we also found that you can combine, there's a way to combine nasal and saliva swabs in the laboratory, and that will push the combined sensitivity of detection up to almost 95%, which is much more comfortable than the nasal or saliva on their own. And so we feel that's a sort of viable alternative as well. And then the graph at the bottom just shows that the saliva CTs were a little bit higher than the NPS and nasal, but did not reach statistical significance. I'm not going to talk about too much about that after the talk from Tim O'Leary on statistics. I'm not a statistician. We also looked at the utility of some of the stabilizing solutions that have been proposed. We looked at 3 different stabilizing solutions. This was just one of them. And we found that they're just simply not necessary. Now, I have to point out that the stabilizing solutions that A lot of the stabilizing solutions that have been reported and have been used were stabilizing solutions that were designed actually for DNA in saliva, for the collection of most of the genomic studies that have been done, and these were the same. The stabilizing solutions for RNA in saliva in general are still only just coming out. So these certainly were not ideal, but we did not expect them to do what they did. The lines in red show just saliva on its own with SARS. In purple is saliva with just VTM, and you can see that the virus just maintains its CT values quite happily for up to a week. And we were very surprised at the stability, even at room temperature. Whereas when we added, this is just one example of a stabilizing solution, it does the same thing with a number of them. It didn't do anything different at 3 days, and actually at a week, we were losing significant signal by the addition of this stabilizing solution. So not only is it not needed, it's actually damaging if you're in a situation where you may actually be delayed in receiving that saliva sample. And so we don't use any stabilizing solutions whatsoever. We just have people spit into a tube and leave it at that. So we've undertaken numerous R&D projects and studies during the course of the pandemic, and will continue to do so. There was a lot of work with assay development, investigation and validation. We actually developed a number of different assays, and we still have a lot of primers and probes on the book that we go back and look at periodically. We have 3 under investigation at the moment, multiple chemistries and platforms, all sorts of sample types and alternative processing methods still being looked at as I speak. Retrospective testing of surveillance sample archives was an extensive undertaking, and hopefully about to be written up to look for evidence of SARS-CoV-2 in New York prior to the first detections in February, March. Also looking at disease pathogenesis, particularly encephalitis, the anatomical distribution of the virus in different areas of the body other than the respiratory system, and most recently the new multi-system inflammatory syndrome described in children. We're doing a lot of work with sequencing, initially the comparison of different next-gen whole genome sequencing methods for just optimal, obtaining optimal sequence depth and coverage of the genome. Also looking at the geographic and temporal distribution of sequence around the state, which indicated different importation from around the globe into New York, and very interesting chains of transmission, some of which stopped, showed sort of dead stops correlating with the sort of orders to shelter in place very clearly. Looking at disease associations with specific SNPs or signatures in the signature, and also signatures in the sequence, and also with severity and fatalities. And also looking to see if we can get some indications of these, what are either repeat infections or reactivations through information from the sequence. And that's on the figure there on the right from Erica, a network analysis map of sequences from throughout the state. Doing quite a bit of work with culture in our BSL-3 lab. First of all, optimization. We've got it growing very well in Vero E6 cells from a lot of specimens now. Interested in growth kinetics and the effect of different host cells on the sequence of the progeny virus. Also looking at the infectivity assessment of the long-term positive patients and the repeat positive patients, and some serology and immune markers. So a lot of different R&D projects and studies with people both inside the Wadsworth Center and quite a few collaborators outside. We never managed to get a photograph of all of our 130 lab staff, unfortunately, but this is a photograph of the supervisors and lab directors who led the team. And I must acknowledge the incredible work of all the virology staff, the search staff, the volunteers at the Wadsworth Center, and other departments in the other departments within the Department of Health, all of the additional agencies and collaborators whose work made the ongoing response of the Wadsworth Center possible. Thank you very much.
Well, Dr. St. George, thank you so much for that really great kind of summary of all the activities at a major public health laboratory. I want to try to ask a couple of questions. We actually have more questions than we have time for. And you may have addressed this in your talk. One is, have you tested any cerebral spinal fluid specimens for SARS-CoV-2, and have you observed any positives?
Yes, we've tested quite a lot. We've actually tested more than 30, and these are from patients with fairly, in the main part, fairly well documented COVID-19 disease. In most cases, they had respiratory specimens at some stage prior, or in some cases almost concurrent, with the encephalitis. And absolutely none of them are RNA positives for SARS-CoV-2. They are universally negative. So this is a very similar situation to what we see with influenza-associated encephalitis, where the CSF is, again, almost universally negative for influenza RNA. Very, very similar situation. So we were not entirely surprised by the finding. We suspected that it might be similar to what we see with influenza, although there were at least a few reports from China of the detection of SARS-CoV-2 RNA in CSF. So we weren't 100% sure what we would find, but it was not a great surprise to us that there's not SARS-CoV-2 RNA in the CSF. But it is important because we continue to get inquiries. We're in the process of writing this up for publication right now, but it's an important finding because I do continue to get phone calls from clinicians wanting to submit CSF for testing with the mindset that the detection of RNA will prove that the encephalitis is the COVID-19 associated. And if people are looking to the detection of the RNA to prove that, it won't do it. It needs to be determined by a sort of clinical association.
I see. Thank you. And maybe a second question before we move forward. Clearly, this pandemic has really highlighted the critical and important role of public health laboratories globally, and certainly specifically in the United States. As a leading public health laboratory based in one of the epicenters of the pandemic, does your laboratory have regular, if you will, almost conference calls with other public health laboratories across the country to share results, to talk about standardized approaches, address supply chain issues? How has that been addressed from your perspective for the public health?
Yes, and there are numerous different mechanisms for that. So we have quite a few different networks for doing that. We have a Northeast regional network specifically where we do that for a regional effort. We have many committees on the APHL, the Association for Public Health Laboratories. We have an infectious diseases committee that interacts on a regular basis with conference calls and the distribution of information and methods and best practices and various and sundry information. Also interacts closely with the CDC, where appropriate the FDA and other government agencies. We also have a specific influenza and respiratory pathogens committee at the APHL, and there are also other CDC 50-state calls regularly throughout any pandemic like this. That's a snapshot. I couldn't even go into all the different ways that we interact. And then there are also less formal interactions between some of the laboratories around the country. So for those of us who experienced some of the larger measles outbreaks, New York was I think the biggest probably, or it was the biggest, but there were other states for example, that had pretty sizable measles outbreaks. And we keep in touch with them and still exchange data and information and so on a sort of less formal basis as well. So there are numerous mechanisms that happens by.
Great. Well, thank you so much. There will be a couple of additional questions that will be sent to you by email for response. Thank you again for an excellent talk. And I'm now going to introduce our next speaker.